The Rise and Progress of Paleontology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Rise and Progress of Paleontology by Thomas Henry Huxley. Essay number 2 from Science and Hebrew Tradition. That application of the sciences of biology and geology, which is commonly known as paleontology, took its origin in the mind of the first person who, finding something like a shell, or a bone, naturally embedded in gravel or rock, indulged in speculations upon the nature of this thing which he had dug out, this fossil, and upon the causes which had brought it into such a position. In this rudimentary form, a high antiquity may safely be ascribed to paleontology, inasmuch as we know that, 500 years before the Christian era, the philosophic doctrines of Xenophanes were influenced by his observations upon the fossil remains exposed in the quarries of Syracuse. From this time forth, not only the philosophers, but the poets, the historians, the geographers of antiquity occasionally refer to fossils, and, after the revival of learning, lively controversies arose respecting their real nature. But hardly more than 2 centuries have elapsed since this fundamental problem was first exhaustively treated. It was only in the last century that the archaeological value of fossils, their importance, I mean, as records of the history of the earth, was fully recognized. The first adequate investigation of the fossil remains of any large group of vertebrated animals is to be found in Cuvier's Recherches sur les ossements fossiles, completed in 1822, and so modern is stratigraphical paleontology that its founder, William Smith, lived to receive the just recognition of his services by the award of the first Wollaston Medal in 1831. But although paleontology is a comparatively youthful scientific specialty, the mass of materials with which it has to deal is already prodigious. In the last 50 years the number of known fossil remains of invertebrated animals has been trebled or quadrupled. The work of interpretation of vertebrate fossils, the foundations of which were so solidly laid by Cuvier, was carried on, with wonderful vigor and success, by Agassiz in Switzerland, by von Meyer in Germany, and last but not least by Owen in this country, while in later years a multitude of workers have labored in the same field. In many groups of the animal kingdom the number of fossil forms already known is as great as that of the existing species. In some cases it is much greater, and there are entire orders of animals of the existence of which we should know nothing except for the evidence afforded by fossil remains. With all this it may be safely assumed that, at the present moment, we are not acquainted with a tittle of the fossils which will sooner or later be discovered. If we may judge by the profusion yielded within the last few years by the tertiary formations of North America, there seems to be no limit to the multitude of mammalian remains to be expected from that continent. An analogy leads us to expect similar riches in eastern Asia, whenever the tertiary formations of that region are as carefully explored. Again, we have as yet almost everything to learn respecting the terrestrial population of the Mesozoic epoch, and it seems as if the western territories of the United States were about to prove as instructive in regard to this point as they have in respect of tertiary life. My friend Professor Marsh informs me that, within 2 years, remains of more than 160 distinct individuals of mammals, belonging to 20 species and 9 genera, have been found in a space not larger than the floor of a good-sized room, while beds of the same age have yielded 300 reptiles, varying in size from a length of 60 feet or 80 feet to the dimensions of a rabbit. The task which I have set myself tonight is to endeavor to lay before you, as briefly as possible, a sketch of the successive steps by which our present knowledge of the facts of paleontology and of those conclusions from them which are indisputable has been attained. And I beg leave to remind you, at the outset, that in attempting to sketch the progress of a branch of knowledge to which innumerable labors have contributed, my business is rather with generalizations than with details. It is my object to mark the epochs of paleontology, not to recount all the events of its history. That which I must now call the fundamental problem of paleontology, the question which has to be settled before any other can be profitably discussed, is this: what is the nature of fossils? Are they, as the healthy common sense of the ancient Greeks appears to have led them to assume without hesitation, the remains of animals and plants? Or are they, as was so generally maintained in the 15th, 16th, and 17th centuries, mere figured stones, portions of mineral matter which have assumed the forms of leaves and shells and bones, just as those portions of mineral matter which we call crystals take on the form of regular geometric solids? Or again, are they, as others thought, the products of the germs of animals and of the seeds of plants, which have lost their way, as it were, in the bowels of the earth, and have achieved only an imperfect and abortive development? It is easy to sneer at our ancestors for being disposed to reject the first in favor of one or other of the last two hypotheses, but it is much more profitable to try to discover why they, who were really not one whit less sensible persons than our excellent selves, should have been led to entertain views which strike us as absurd. The belief in what is erroneously called spontaneous generation, that is to say, in the development of living matter out of mineral matter, apart from the agency of pre-existing living matter, as an ordinary occurrence at the present day, which is still held by some of us, was universally accepted as an obvious truth by them. They could point to the arborescent forms assumed by hoar frost and by sundry metallic minerals as evidence of the existence in nature of a plastic force competent to enable inorganic matter to assume the form of organized bodies. Then, as everyone who is familiar with fossils knows, they present innumerable gradations, from shells and bones which exactly resemble the recent objects, to masses of mere stone which, however accurately they repeat the outward form of the organic body, have nothing else in common with it, and thence to mere traces and faint impressions in the continuous substance of the rock. What we now know to be the results of the chemical changes which take place in the course of fossilization, by which mineral is substituted for organic substance, might, in the absence of such knowledge, be fairly interpreted as the expression of a process of development in the opposite direction, from the mineral to the organic. Moreover, in an age when it would have seemed the most absurd of paradoxes to suggest that the general level of the sea is constant, while that of the solid land fluctuates up and down through thousands of feet in a secular ground swell, it may well have appeared far less hazardous to conceive that fossils are sports of nature than to accept the necessary alternative, that all the inland regions and highlands, in the rocks of which marine shells had been found, had once been covered by the ocean. It is not so surprising, therefore, as it may seem at first, that although such men as Leonardo da Vinci and Bernard Palissy took just views of the nature of fossils, the opinion of the majority of their contemporaries set strongly the other way, nor even that error maintained itself long after the scientific grounds of the true interpretation of fossils had been stated, in a manner that left nothing to be desired, in the latter half of the 17th century. The person who rendered this good service to palaeontology was Nicholas Steno, professor of anatomy in Florence, though a Dane by birth. Collectors of fossils at that day were familiar with certain bodies called glossopetrae, and speculation was rife as to their nature. In the first half of the 17th century, Fabio Colonna had tried to convince his colleagues of the famous Accademia dei Lincei that the glossopetrae were merely fossil sharks' teeth, but his arguments made no impression. 50 years later, Steno reopened the question, and, by dissecting the head of a shark and pointing out the very exact correspondence of its teeth with the glossopetrae, left no rational doubt as to the origin of the latter. Thus far, the work of Steno went little further than that of Colonna, but it fortunately occurred to him to think out the whole subject of the interpretation of fossils, and the result of his meditations was the publication, in 1669, of a little treatise with the very quaint title of De Solido Intra Solidum Naturaliter Contento. The general course of Steno's argument may be stated in a few words. Fossils are solid bodies which, by some natural process, have come to be contained within other solid bodies, namely, the rocks in which they are embedded; and the fundamental problem of palaeontology, stated generally, is this: "Given a body endowed with a certain shape and produced in accordance with natural laws, to find in that body itself the evidence of the place and manner of its production." The only way of solving this problem is by the application of the axiom that "like effects imply like causes," or, as Steno puts it, in reference to this particular case, that "bodies which are altogether similar have been produced